Hi guys, this clip is just to talk about lists of objects and some things you can do with them, and to talk about the IComparable interface and using the ToString method on an object. So first of all, I'll just show you some of my code I've created. So if you ignore all the commented stuff, because we'll come back to all that later and put it in, I've created a class OU student, which has a first name, a surname, and a personal identifier. And a constructor there, as you can see, and all the constructor does is set up those three properties with their default values. And then in my form, then all I do in the form constructor, so I've defined up here a student, defined a student list, which is a list of OU student objects. So remember, you can have lists of integers, lists of strings, lists of OU student objects, so lists of any object that you want to. And then in the form constructor, I've created a new list. So I've instantiated a new list, and then I've added 3 new OU students to it. Now then, what I've got 3 text boxes, and what I've tried to do is I've tried to populate those using ToString. So you'll be familiar with ToString because we've done it quite a bit with numbers and things like that. So I've tried to ToString those objects. So if we just run this and see what happens, then you'll see that the ToString version of an object is just its object name at the moment, or its class name, sorry, which is not ideal. So the first thing that we're going to do is we're going to have a look at making that ToString function return something a bit more sensible. Now, ToString is something that is inherited in any objects. It's part of the object-based class. So all classes that you write are going to be subclasses of objects, so it will inherit ToString amongst other properties as well, methods as well. So have a little look. So what we're going to do is we're going to decide what a ToString representation of our object is. Now, there may not be one. So the generic object ToString will always return, as you've just seen, the class name, and it might be that your object has no sensible string representation of it, but in this case we have got a sensible string representation. So we're going to return, better put a space in, we're going to return, so the ToString for our student is going to be their first name and their surname concatenated. So then if we just have a little play with that, see if that works. So now you can see that the text boxes are being populated with the ToString version of each object. And you can make that whatever you want. So if in this case it made more sense to be first name, surname and personal identifier concatenated together, it could be. Let's have a little play with that and see what happens. So the other thing that we're going to look at today is going to be sorting. So a list has got a sort method, but like when we talked about having a ToString representation of an object, it doesn't necessarily make any sense to have one, and some objects it doesn't make any sense to sort them either. So there's only certain things that will have a natural sort within a list. So if we tried to sort our current list, then it throws an exception, because as far as the code is concerned, it's got no logical way to attempt to sort OU student. It doesn't understand what's in it. We've defined our fields and things like that, so we understand how they work and what's logical, but the compiler can't just second guess on how you want to sort it. So the way that you tell it how to sort things is by implementing something called IComparable. And IComparable basically says that this class or this object can be compared to another class, to another object. And I've got another clip, if you're not quite sure on interfaces on how they work, I've got another clip on how interfaces work, so have a look at that one. But basically IComparable is an interface that can be implemented in any class at all if it has a sensible comparison with another. So first of all we need to do, I've created a few sort of variables here that I'm going to use just to remind me to do them. So your compare to function, which you need to implement if you're going to use the IComparable interface. Basically this is how you tell whether something is less than or equal to or greater than the thing that you're comparing. So first of all, we need our compare to object, which at the moment it's passed in as just an object, but we know it's going to be an OU student. So I've defined here an OU student we're going to use. So this is the thing we're going to compare our current OU student. So when this is called, this will be an object, so it'll be an instance of OU student, and we're comparing it to the thing that's passed in as obj. So the most obvious thing to compare here, because we've got first names and surnames, if we're going to do some sort of comparison, so which of these students is greater than or equal to the other, then we could do this on names. So if we look at surnames first of all, then you'll find that we have a string compare method, and this string compare method accepts two strings, and it will return you an integer. So in this case, our compare to method returns an integer, and it's -1, 0, or 1 depending on how the comparison happens. So if we look at comparing surname to the object we're using, so this will compare the surname. If the surnames are equal, it will return 0. Otherwise, you'll get a 1 or a -1 that will just say which way round it is. So that's looking at surnames. If we've got equal surnames, then we... my typing's not great, is it? If we've got equal surnames, then that will return 0. In which case, we'll need to start looking at first names too. So then we'll use our overall comparison is we'll look at comparing the first names as well. So we'll use first name from the object we're in, and then we'll look at the compared to object first name as well, and put that into overall comparison. If the surnames are not equal, then for efficiency we can just say the overall comparison is the same as the surname comparison, because if they're not the same, you'll already know how they're ordered. And then we just need to return the overall comparison, and that will tell you how this fits within any sort of natural ordering. And then if we run it up, so this is how the objects are added to the list. And if I click the sort button, then it will sort the list according to our compared to that we've used, and that's the new compared to the sorted list. So that's a sort of quick way of just showing you how there's lots of little interfaces that you can use and how they work for sorting lists. If you've done some of the Java courses, so M255 or its replacement M250, then you'll also know about a few other functions that are overridden from object, and they all work in the same way. So have a little play about with using the compare to function, and have a look at what other functions that are inherited from object and what you can do with them. So I hope that's been useful, and I'll see you for another clip again soon. Thanks very much.